Hello, this is Ms. McLean, and this is a short video where I'm going to explain many different types of probability problems from Chapter 4. This lecture is not going to cover all of the types, but it is going to cover quite a few. So let's go ahead and look at our problem. It reads, a population of 592, which this is important. This number right here is going to stand for our total. And our total is going to represent our sample space. Okay, so I know that this number is going to be my denominator for many of my questions. It might not be all of them, but it is going to be for most. Okay, so a population of 592 semiconductor wafers contains wafers from 3 lots. So here's the 3 lots in our chart. The wafers are categorized with results shown in the following table. A wafer is chosen at random, and then it tells us to round 4 decimal places, okay? So let's go ahead and read our first question. It says, what is the probability? So I'm going to emphasize the word probability. That tells me my answer needs to be in between 0 and 1. So we want the probability the wafer is from lot B. So with that, we're going to look at our row that represents lot B. So lot B, I am going to add up 160 plus 36, and that's going to give me my event. So your event always goes in the numerator. The event always comes from the question. And then, of course, our total, 592, our sample space is going to go in our denominator. And 592 comes from, if we add up all these values, you should get 592. So let's go ahead and calculate this in our calculator. 160 plus 36 gives us 196. And if we divide by 592, we get the decimal 0.3311. Okay, so if we round 4 decimal places, the 0, because of the 8, becomes a 1, right? So that's the probability for part A. Now let's look at part B. It says, what is the probability the wafer is non-conforming? So for non-conforming, that means we're going to focus on this, this column. So that's going to be our event. I'm going to add up 10 plus 36 plus 32. And our denominator, once again, is that total of 592. So part B is very similar to part A, except now we're looking at the column instead of looking at the row. So I'm going to go to my calculator. Let's do these calculations. That's 78. Divided by 592. And again, if we round 4 decimal places, 0.131, and the 7 is going to become an 8. All right. Now let's look at letter C. Letter C is a little different from A and B. Letter C, once again, we're finding the probability that the wafer is from lot B and non-conforming. Now, this is an and problem. Typically, I usually say when you see and, that means multiply. But really, multiplying occurs when there is multiple events happening. And for this particular problem, a wafer, that means one wafer is being chosen. One event is happening. So that means we don't multiply. We only multiply when it's multiple events, okay? So we're not going to multiply. And on top of that, we actually have that answer. It's given to us in our chart. So where is lot B and non-conforming? So where do these two intersect? They intersect at 36. So we're going to take the 36 and divide it by 592. And that's going to give us our probability. So 36 divided by 592 gives us the decimal 0.0608. Okay, so again, 4 decimal places. Right, letter D says, what is the probability that the wafer is from lot B or non-conforming. Okay, so we are choosing our wafer, and we want our wafer to either be in the category of lot B or non-conforming. Okay, so I'm going to go ahead and circle. Here's our lot B. Here's the non-conforming. And when it comes to OR, we automatically add. Okay, so I know I'm going to have to add up all of my lot B, and I'm going to have to add up all of my non-conforming. Now, you can see in my picture that one value gets circled twice, right? That's actually what C gave us, okay? So the value that we're circling twice is being counted twice. And so what that means is we're overcounting, all right? And we don't want to overcount. Therefore, we do have to subtract. So we're going to have to subtract this probability. Okay, so this is what we're doing. Probability of event A plus probability of event B minus the probability of A and B. Right, so probability of event A, that's lot B, that comes from part A. So actually you can go and grab your answer from part A if you want. Just be careful, don't grab the rounded answer. So if I were you, I would keep it as a fraction. So 196 over 592 plus event B is the non-conforming. So that was letter B. So that answer, I'm just going to quickly add this up since I erased my work. So what was that? 78 out of 592. And then we want to subtract 36 out of 592. So in my calculator, I'm going to go ahead and do the numerators. So 196 plus 78 minus 36. That gives us 238 out of 592. So I'm going to divide by 592. And this equals to 0.4020. Okay, so that's the probability of pulling a wafer that would either be from lot B or non-conforming. Right, up next, we have letter E. What is the probability the wafer is not from lot B? So I'm going to go ahead and erase my circles here because this problem is different. And when we see the word not, that means that this is the complement. So our rule of complement says we start with 1 and we subtract the event. Okay, so the event in this case would be lot B. So if I take away lot B, it's going to leave me with all of the values that are not in lot B. Okay, so for this particular one, you can follow your rule of complements, or since we have a chart, you can actually just ignore the lot B row. And if I add up these values and divide by 592, this should give me the same solution for part E as it does with the complement formula. Okay, so again, since they give us a chart, we have all our information here. You can just kind of X out lot B, add these up, and divide that by 592. You get the same solution. Okay, I'm going to go ahead and show you both. So I'm going to first begin with the rule of complements. So lot B, I'm going to add up 160 and 36. So that gives me 196. And now I'm going to subtract. So 1 minus 196 divided by 592. And that's giving us the decimal 0.6689. Okay. So again, I'm going to prove to you that you can do this 2 different ways. That's your rule of complements. So now I'm going to just cover up my lot B's and I'm going to add up. So 88 plus 10 plus 266 plus 32. So 396 if I divide by 592. Notice we get the exact same decimal. Okay, so it's the exact same decimal, same method. Okay, either one is correct. Let's look at letter F. So F and G are going to be your conditional probabilities. Notice it is starting with the word given. So let's focus on F first. Given the wafer is from lot B. So what that means is we don't care about C, we don't care about A, right? So again, the given is telling me it's from lot B. So we ignore the other information that's given in our problem, okay? So given that it's from lot B, so that means my denominator is going to be lot B, which is 160 plus 36. And then if we continue, it says, what is the probability that it is non-conforming? Now, again, we don't care about the 10 and 32 that was non-conforming because those belong to A and C. So we want the 36, okay? So the 36 belongs to lot B and it's non-conforming. Okay, so that's how we're getting those values. I'm going to go ahead and calculate this in my calculator. Since we have addition in the denominator, you can put this all in your calculator at once, but you have to use parentheses. I'm going to open my parentheses and type 160 plus 36. Once I hit equals, there's our probability. So 0.1837. So that 6 is going to round up to a 7. Right, let's go ahead and look at part G. This time it is given the wafer is non-conforming. So what that means is now I am focusing my problem with the non-conforming. So I don't care about the conforming now. Now I only care about non-conforming. So I'm going to leave this up just so you can see the difference between the two problems. So this was letter F, and I'm going to work out G up top. So G, now we want non-conforming in our denominator. Okay, notice for F, denominator belonged to lot B. This time we want non-conforming. That given part needs to be in our denominator. So that means I need to add up 10 plus 36 plus 32. That's our new sample space. From the non-conforming, I want the probability that it is from lot B. Okay, so from this row, what is from lot B as well? And that's the 36. Right, so this is lot B and non-conforming. So the numerator is staying the same, but that denominator is changing because what they gave us was different. Okay, so I'm going to go ahead and calculate this in my calculator. I'm going to use parentheses once again. So 36 divided by, open parentheses, 10 plus 36 plus 32. And this gives us 0.4615. Okay, so our probabilities should be different because, of course, our sample space is different. Okay. All right, sorry about those technical difficulties. Let's move on and let's look at the last one, letter H. Right, so H reads, let E1 be the event the wafer comes from lot B. Okay, so I'm going to go ahead and erase. And I'm going to recircle just so you can see what we're concentrating on. All right, so that's my E1. Let E2 be the event the wafer is non-conforming. So this is our E2. Are the events E1 and E2 independent? So let's talk about that definition of independence real quick. For independence, the probability of lot B would not affect the probability of E2. Okay, so the probability of E1 does not affect the probability of E2. That's what independence is. Now, if I look at this though, since 36 is part of lot B and it's non-conforming, it would affect the probability. Okay, so lot B and non-conforming, those probabilities do affect one another because I could have a lot B that's non-conforming. So are these independent? They're not. okay? An example of independence would be a wafer from lot A and a wafer from lot B. So see how the two rows don't really interact with each other? That would be independent events, okay? Let's look at our next one. Are the events E1 and E2 mutually exclusive? So I want to remind you that mutually exclusive is where we have completely separate events and they don't overlap. But we do have that overlap with 36. So therefore, these are not mutually exclusive events. Okay, so E1 and E2 is a neither. It's not independent and it's also not mutually exclusive. Okay, so hopefully a quick little rundown of seeing a lot of chapter 4 probability questions can help you with your studying. If you've got any further questions, feel free to email me.